Okay, so what if I told you that our whole idea of space being this quiet, silent, unchanging place is just wrong? The universe isn't some static photograph. It's a high-speed action film, jam-packed with sudden flashes and cosmic explosions. And for the very first time, we're about to hit play.
You see, for decades, our view of the cosmos was basically like this image on the left. Beautiful, yeah, but ultimately just a still photograph. We now know the reality is much more like the image on the right. It's dynamic, it's colorful, sometimes it's incredibly violent, and it is constantly changing. The most important events in the universe are often the fastest. They appear and then disappear in the cosmic blink of an eye.
So yeah, this shift in perspective is honestly one of the most exciting things happening in modern astronomy. We are officially leaving behind the idea of space as a fixed backdrop and starting to see it for what it truly is, a place of constant, high-speed action.
And this quote right here, it just nails it. The whole assumption that what you see in the sky one night will be there the next, well, it's fundamentally wrong. It turns out the universe has this cosmic heartbeat, and we're just now finally learning how to feel its pulse.
The official name for this whole new frontier is Time-Domain Astronomy. And it's a pretty simple idea, but it's totally profound. We're basically moving from cosmic photography to cosmic cinematography. We're not just taking snapshots anymore. We're filming the greatest show in existence.
So how do you film a movie this big? I mean, a movie that's the size of the entire universe? Well, you need a revolutionary new kind of camera. And that camera is the Vera C Rubin Observatory, getting ready to start its mission from the crystal-clear skies of Chile. This thing isn't just another telescope. It's a cosmic scanning machine.
And here's what makes it so incredible. Its eye is a 3.2 billion pixel camera. That's 3,200 megapixels, making it the largest, most powerful digital camera ever built by humans. The level of detail it can pull in, it's just staggering.
To try and put that into perspective, if you wanted to see just one of its images at full resolution, you'd have to line up 1,500 high-definition TVs. Can you even picture that? That's the staggering amount of information packed into every single shot.
And it takes these shots over and over and over again. Every single night, the Rubin Observatory is going to generate 20 terabytes of data. That's not a stream of information, it's a data tsunami. We're creating a digital copy of our universe that we can check for changes every single morning.
Now, this comparison really helps clarify what Rubin is all about. Many of us have heard of the amazing James Webb Telescope, right? Well, think of Webb as a cosmic microscope. It zooms way in on one tiny patch of sky with incredible detail. The Rubin Observatory is the total opposite. It's a super wide-angle lens capturing a massive chunk of the sky, 40 times the size of the full moon, in a single go. Its job isn't to zoom in and stare, its job is to scan. Okay, so what kind of wild action scenes are we going to find in this new cosmic movie? Let's start with one of the most violent and straight-up baffling mysteries in the cosmos: fast radio bursts.
I mean, this is the central question that keeps astronomers up at night. What in the universe could possibly release 80 years of our sun's entire energy output in a single millisecond?
These events are called fast radio bursts, or FRBs for short. They are these unimaginably powerful blasts of radio waves that come at us from billions of light years away. And they are so brief and so unpredictable that catching one in the act has been nearly impossible. Well, until now. And this right here illustrates the sheer mind-bending scale we're talking about. Just look at that comparison. On one side, 1/1000th of a second, literally less than the blink of an eye. On the other, nearly a century of our own star's total power. The physics at play here are just extreme.
So what could possibly cause something like this? The leading suspect is an incredibly exotic object called a magnetar. It's the super-dense, collapsed core of a dead star, with a magnetic field 1 trillion times stronger than Earth's. Scientists think a violent starquake, a crack in its solid crust, could unleash this kind of impossible energy.
But these millisecond mysteries are just one scene in the movie. The Rubin Observatory will also be filming the universe's great factories, exploding stars called supernovae. And as we're about to see, this isn't just rare chaos, it's a constant, life-giving process. Okay, get ready for this number. Every single second, approximately 50 stars explode somewhere in the universe. Not every hour, not every day, right now, dozens of times over.
The sky is constantly blinking with the light of dying stars.
So why does this matter to us? Because these explosions, these supernovae, are cosmic forges. They create heavy elements like the iron in your blood and the calcium in your bones. Then they blast those building blocks of life across the galaxy. Filming them in real time is kind of like watching our own origin story unfold.
But there's a more immediate, a practical reason we need to watch this movie. The Rubin Observatory isn't just making a film for the archives, it's running a real-time cosmic alert system for the entire planet. And here's how it works. The telescope scans the sky. An algorithm instantly compares the new image to the previous one. If a single pixel has changed, if a star has appeared or vanished or just brightened, the system automatically fires off an alert to astronomers all over the world. And it does all of this in less than 60 seconds. It's amazing. This system is going to let us catch incredible events the moment they happen. We'll see kilonovae, the actual collision of neutron stars where all the gold in the universe is forged. We'll get to witness black holes shredding entire stars. And crucially for us, we'll be able to spot and track asteroids that might pose a threat to Earth, giving us that precious time to react.
Ultimately, it all just comes back to this one powerful idea. The era of static space is officially over. For the first time in human history, we have a camera that's actually capable of capturing the cosmos in motion, of catching the universe in the act.
Which leaves us with this final thought. For millennia, the sky has been filled with fleeting, powerful events. The universe has been blinking all along. The question was never if it was happening, but when we would finally be ready to watch.